What is up, math superstars? In this edition of Mr. Peterson Presents, we're talking about this word right here called sequences. So when we talk about sequences, all we're talking about is a pattern that shows up with a set of numbers here. And so here you're given a couple different basic vocabulary words that you'll use in this lesson. So the first one is we have the word term here. When we see the word term, all we're talking about, this is a number in the sequence. So it can be any number in the sequence. And the second word we're looking at here, you'll see the rule. So when we talk about the rule, this is going to be just very simply the pattern of the sequence. So right now we have 4 different examples of different types of patterns that we'll talk about here in 6th grade math. So our first type here, we are given this set of numbers right here. We're given a set 1, 3, 5, and 7. So in this pattern, we have to figure out how did we go from 1 to 3? And then how did we go from 3 to 5? And how do we go from 5 to 7? So in this pattern, it has to be the same operation and the same number that we get there. So in order to go from 1 to 3, we can figure this out that we're going to be adding 2 to this to go from 1 to 3. And then to go from 3 to 5, this rule will be adding 2. And then we're adding 2. So anytime you have an addition problem where we're adding 2, this is actually called arithmetic sequence. Arithmetic sequence. And so if we're going to be adding 2 to find the next number, so the question always comes out, what is the next number or term in the sequence? So to find the next number, what we do is we use the letter n. We're going to make a little expression here. The letter n talks about the last term in the sequence, 7. And then we add our rule in, plus 2. So in order to find that, if we took 7, say if we changed out n for 7, plus 2, our next number in the sequence would be 9. And we can keep that pattern going if we wanted to find the next number after 9, the next number after that. We would just use a simple rule here, n plus 2. So we take the last term of the sequence to find the next number. So this is our rule. And we can also call this rule, we can call this is actually called the common difference. So what did all these numbers share in common? That we added 2 from the previous number to get that number. So here's example number 2. We have these numbers here, 100, 96, 92, and 88. So we got to figure out how we go from 100 to 96, and then from 96 to 92, and it has to be the same operation and same number for it to count here. And so to go from 100 to 96, we know that we are subtracting by 4. And then if we're going from 96 to 92, we are subtracting by 4. And then from 92 to 88, we are subtracting by 4. So if we're going to deal with an addition or subtraction problem, the subtraction problem, these are also called arithmetic sequences. And to go to the next number in the sequence, what we do is we use the letter n. We'll talk about the last term in the sequence. And then if we subtracted 4 from that, so the way this would look is if we did 88 minus 4, our next number in the sequence would be 84. And so we also call this, since it's sharing, subtracting 4, this is also called the common difference. So all we're looking for is a common pattern amongst a set of numbers. So now here's example number 3. We're given this set of numbers here. We're given 1, 3, 9, 27. So we can already kind of tell that addition and subtraction will not work because the numbers jump. So it would go from 1 to 3, we'd be adding 2. To go from 3 to 9, we'd be adding 6. To go from 9 to 27, we'd be adding 18. So we know that the addition won't work here. So, but what we know is that if we multiplied by 3, so 1 times 3 to give you 3, and then if we did 3 times 3, it gives us 9. 9 times 3 would give us 27. So we can see that our pattern emerges here that we are multiplying by 3. And we call the name of this sequence, this is called the geometric sequence. So in order to find the next number in the sequence, the way we'd set that up is we'd use the letter n would be the last term in the sequence. And we would multiply that by the pattern we discovered as times 3. So in this case, we would have 27 times 3, and that would give us the next number in the sequence to be 81. And so we can also, instead of calling this geometric sequence, we can also find out that we can call this the common ratio. So all we're doing is we found our pattern. Amongst the numbers, we're trying to find our next number in the sequence. And we can also call these two types of things. We can call it a geometric sequence, or we can find the common ratio. So here's our last example for this video here. So we're given these 3 numbers here. We're given 81, 9, and 1. And so we know that subtraction really wouldn't work for this. So why don't we try division? So 81 divided by 9 is going to give us 9. And then 9 divided by 9 is going to give us 1. And if you're stuck on what to divide by, you can always use a calculator and type in your calculator 81 and then divided by sign and then the next term in the sequence. So you do the first term divided by the second term will give you what you divide by. And so the question is, we need to come up with the next number in the sequence. So, but in order to figure that out, the type of the sequence, this is also called a geometric sequence. And so the geometric would be if you're either multiplying or dividing by a number. So to find the next number in the sequence, we take that last term is 9 and we divide it by the pattern. So for us, it's dividing by 9. The way this would look is we do 1 divided by 9. And that would give us, we can write this just as a fraction, 1 over 9. So if I wrote that down in the sequence, next term in the sequence, 1 over 9. So it's actually the inverse of 9. So this is kind of fun if you're doing the division sequences to figure out the next term of the sequence. So this term right here would be the inverse of 81. It would just be 1 over 81. So all we're doing is dividing by 9. And we can keep doing that, and you can realize that it's just the inverse. So another name for this rule, we can also call this is also called the common ratio. Here, so we have 4 different types of sequences for you. We have 2 that are called arithmetic. So the arithmetic is where we either add or subtract by a number. The geometric is where we would multiply or divide by a number. And you just got to remember which set is called the common difference, which is where we add or subtract. And then the common ratio is where we multiply or divide. So why don't you go ahead and try your classwork page. Make sure you get your video notes checked also, because we'd love to check and see your awesome and amazing work.